All right, so I've heard from some of you that we need a little bit more practice with stoichiometry problems and limiting reactant problems. So we're going to go ahead and do this extra practice. You can find the link above in my webpage. But the first step most of the time is to go ahead and write the chemical reaction. Wow, that was fast. Okay, so now that we have our balanced equation written, let's go ahead and actually read through the problem. So we have acetic acid, which is the HC2H3O2, reacting with our aluminum hydroxide, AlOH3, to form water and aluminum acetate, which is going to be a aqueous solution. So, number 2, which is the important part. This is the stuff that we're really getting tested on, no longer in review. It says, using the equation from problem 1, determine the mass of aluminum acetate. So this is going to be what we're solving for. That can be made if I do this reaction with 125 grams of acetic acid and 275 grams of aluminum hydroxide. So with every limiting reactant problem, we are going to do 2 strings of conversions. And when we talk about the mass of aluminum acetate, we are trying to find out how many grams of this product we are going to make. I'm starting out the problem with 125 grams of this and 275 grams of this. So what we need to do is convert this reactant into this product, and we need to convert this reactant into this product in order to figure out the mass of the aluminum acetate that will be made. The reason for that is because we have to determine the limiting reactant. We know that one of these two is going to run out, either 125 grams of acetic acid or 275 grams of aluminum hydroxide. One of them is going to run out, and that's going to determine the amount of our product that we can make. This answer will be our theoretical yield. So whatever comes out, this is going to be our theoretical yield. How much of our product we can make. Okay, so we're going to go ahead and get started. With each of these reactants, we are going to take them and put them over 125 grams of HC2H3O2. It is very important for you to write out not only the unit, but also the label. Are you in grams or are you in moles? Which of the 2 reactants or products are you talking about? Because once we get to the mole ratio step, that's going to become really important. So, every time you do a conversion, you are going to take those units that you start with, and they're going to be dropped kitty corner or diagonal to where you started with, HC2H3O2. Now, I know the grams have to go on the bottom here because that's what I started with, but the question is, where am I going? Remember, we are solving for the mass of aluminum acetate. So we are basically doing a grams to grams conversion. That means that if we were on our mole bridge, we would have to go from grams to moles of B. This is moles of A, this is moles of B. And then we would have to finally do our final conversion to get into grams of that B. So the first step is going to be, in every case, to make sure that your given value is in moles. So we got to do a dividing by the molar mass situation. We're going to convert from grams of HC2H3O2 into moles. That means that we are going to divide by the molar mass. So what we have to do here is figure out what our molar mass is of acetic acid. Oh my gosh, that was so fast. So this term converted us from grams of acetic acid to moles. You always have to do this if your given value is in grams, because the next step requires us to convert from moles of C2H3O2, oops, that's HC2H3O2. We have to convert that from moles of this to moles of our wanted value. Remember, we're solving for aluminum acetate. That's going to be AlC2H3O23. This step is the mole ratio. This is the only way to convert from one substance to another substance. It's the only way to do it. So now we have to figure out what numbers go with those two units. So when we do the mole ratio, we go back to our balanced equation and we look at the coefficient. That's the big number in front of the compound. So for every 3 moles of acetic acid, that came from here, I will make 1 mole of AlC2H3O23. That's our mole ratio. This comes from the balanced equation. Now that we're currently in moles of Al2CH3O23, okay? We've gotten rid of grams of acetic acid. We've gotten rid of moles of acetic acid. So now we're left with moles of this new product. So then we have to convert to grams. At the end, you're always going to be multiplying by the molar mass because this mole comes down to the bottom here. Moles of AlC2H3O23. And to convert to grams, we want to multiply by that molar mass. And look, grams divided by moles. This is where your molar mass is going to go. AlC2H3O23. So I'm going to really quick figure out my molar mass of Al2CH3O2. Okay, so now that we've got our molar mass in there, we want to look at this very last step. This very last step takes us from moles into grams of our new substance. That's why this time we multiplied by the molar mass. Here we divided by the molar mass because we're going away from our grams. Okay, so we're going to go ahead and calculate this all out, multiply everything on top to get 25513.75, and then we're going to divide that by everything multiplied together on the bottom, which is 180.18. Then we're going to go ahead and divide these, which will get you 142. That is with significant figures. We are allowed 3 of them. Now, I want to make sure that I have canceled out all my units. Moles of this, canceled out with moles of this. So that tells me that the only thing that didn't get canceled out is what my units are going to be for this problem. So my answer is in grams of AlC2H3O23, which is good because that is what I'm solving for. We're going to now repeat the same procedure really quickly with our 275 grams of aluminum hydroxide. I'm going to go ahead and do this now. You can pause here and then hit play when you're ready, and you can check and make sure you've done it correctly. All right, so let's go ahead and check and make sure we've got all of our units canceled. Grams of AlO3, grams of AlOH3, moles of AlOH3, moles of AlOH3, converted with our mole ratio to moles of AlC2H3O23. That also cancels. We are left with grams of AlC2H3O23, which is good because now we have 2 answers with the exact same units. Perfect. Let's review how we got here. First, we converted from grams to moles by dividing by the molar mass. Then we took a look at our mole ratio, which told us for every 1 mole of AlOH3 that we react, we can make 1 mole of our product. And then finally, we converted here from moles to grams by multiplying by the molar mass of that new substance. Okay, so then we've got two answers here. We've got 142 and we've got 720. So now the question is, what is the limiting reagent or reactant in this problem? Well, this is the part where you choose the smaller answer. 142 is the smaller answer, which tells us that acetic acid is our limiting reactant. Why is that? Well, because acetic acid produced the least amount of our product, that means that acetic acid will run out first, limiting us to only making 142 grams of our product. We will run out of acetic acid before we ever even get close to making 720 grams. So our limiting reagent is acetic acid, and our theoretical yield is going to be 142 grams of our product. So the next thing that I want to talk to you about is calculating the amount of excess reagent that will be left over. We just went through all of that work to determine the limiting reactant was our acetic acid. So what we're going to do is take that limiting reactant and we're going to start over. The limiting reactant runs out first, so it's going to determine not only how much product we make, but how much of the AlOH3 that we're going to use. So we are going to convert from our 125 grams of acetic acid, and we are going to convert that into grams of our excess reagent. So if you reworded that question, it's kind of nice to think about it this way. If you have 125 grams of acetic acid, how much of the excess reagent will be used? We'll start there. Okay, so this is how you're going to set this up. First, you have your mole conversion, converting from grams to moles of that limiting reactant, which is the same thing we had to do before. Then we have our mole ratio. That mole ratio will tell us for every 3 moles of acetic acid, we can use 1 mole of AlOH3. Then finally, we multiply by the molar mass to go from moles of substance B to grams of substance B. Then we're going to go ahead and calculate. So what we've learned here is that 54.1 grams of AlOH3 are used when we react 125 grams of acetic acid. The problem here is that we want to know how much of the excess reagent will be left over. So we know that we started with 275 grams of AlOH3 and we used up 54.1 grams of AlOH3. So at this point we're going to go ahead and subtract 275 minus 54.1 and you get 220.9. However, with significant figures, we are only allowed to go to the ones place. So we have to use this 9 to round up. We end up with 221 grams of AlOH3 remaining. Let me know if you have any questions. Send me an email. Hopefully this was helpful for you, and good luck.